Today's lesson is about compound inequalities. So as you can see from my definition, a compound inequality is when you take two separate inequalities, you join them together by either an and or an or. So if you look down at number 1 down below, that is an or inequality because it has the word or in between them. You'll see different types. The and inequalities won't always have the and in between them, but they still will be an and. I'll explain one of those in just a few minutes. So let's go ahead and start this example. So we're going to solve and graph. When you solve this problem, it's actually very easy if you understand the stuff we did from the previous section. If you didn't understand the stuff from the previous section, it'll be very hard. So make sure that you got that before you try these. So what we're going to do is we're going to solve each of these two parts of this inequality, the 2x plus 3 is less than 9, or 3x minus 6 is greater than 12. We're going to solve each of those separately. Starting with the 2x plus 3 is less than 9, I'm going to subtract 3 from both sides. That gives me 2x is less than 6. If I divide both sides by 2, I get x is less than 3. That's the first half. If you want to pause, you can try the second half on your own. So you're going to add 6 to both sides. You get 3x is greater than 18. You divide both sides by 3. You end up getting x is greater than 6. So your final answer is actually going to be written out as x is less than 3 or x is greater than 6. So make sure if you start out with an or in the beginning of the problem, just make sure that you move that or to the very end of the problem. So that's your answer for that one. So let's graph it. When you graph this, you are actually going to be graphing both x is less than 3 and x is greater than 6 on the same number line. So x is less than 3, this is an open circle. Less than 3 is numbers like 2, 1, negative 20, they're all less than 3. So we're going to go to the left of the 3 to show that we're less than it. So then the other thing we do, x is greater than 6, open circle again. We're going to go to the right of it to show that we're greater than 6. And that's our two-part answer for that problem. So the next one, I want you to try it on your own, and you can just go ahead and pause it and give it a try. There's several steps to it. So please pause, try this one on your own. I still want you to solve and graph. Okay, so if you've tried this one, hopefully it was okay. You're going to subtract 2 from both sides. You get 5n is greater than negative 20. If you divide both sides by 5, you get n is greater than negative 4. That's the first part of the answer. Second part, we have a little bit more work to do. We're going to distribute the negative 3. You end up getting negative 3n minus 12 is greater than 21. If you add 12 to both sides, you get negative 3n is greater than 33. And you end up getting n is less than negative 11. Don't forget, when you divide both sides by negative 3, you end up reversing your inequality sign. So now we're going to write out our answer as n is greater than negative 4 or n is less than negative 11. So let's graph. So be careful when you draw these graphs for negatives because they go in the opposite order of what you would do for positives. I know it seems very obvious for many people, but you have no idea how many times I see people making that mistake. It happens a lot. So let's go ahead and draw this. You're going to show n is less than negative 11, which means you go to lower numbers than negative 11, like negative 12, negative 13. N is greater than negative 4 is going to be higher numbers than negative 4. So it's going to go in two opposite directions. And you'll actually find for nearly every time you have an or inequality, you have two arrows going in opposite directions. So what this means is that your answer can be in either of the blue areas. We don't know what n is. All we know is that it's going to be either greater than -4 or it's going to be less than -11. By the way, one way to tell if you've made a mistake is if you get something like where you have a number line, and on your number line you have two things going in the same direction, you're going to never get this. So if you end up getting an answer like that, that is a sign that you made a mistake. Usually the mistakes come from forgetting to reverse inequality signs, so just keep that in mind. So our next type is an and inequality, and you'll find that these ones look a little weird. There's actually two methods for solving them. I'm going to show you both and let you choose what you want to do. So this is an and inequality. So there's two ways to do it. I'm just going to show you and tell you how you would solve it using the first method, and then I'm actually going to show you the second method. Many students I've noticed like the second method better, but the first method you can do is you can rewrite this. So what you can do is you can rewrite the first half of it as -3 is less than or equal to 2x minus 1. Then you write and. The second part of it would be you keep the 2x minus 1, but you rewrite it as less than or equal to 5. So if you want to do it that way and solve each of these sides separately, like each of these inequalities separately, that is fine. That will give you the same answer in the end as the one that we're going to get doing the other method. So that's method 1. It would be to split it up. So it's the same as that. So let's do method 2. And method 2 is usually the favorite of most people because it's more fun and it requires a little bit less work. So what we're going to do is our goal is to get this x by itself. So we're going to try to solve for x. That's our goal. So what we need to do is we need to move over everything that's in the same part of the inequality as that x. I'm going to start with a 1 by adding 1 to everything. So what I have to do is I'm going to add 1 not only to the middle part, and not only to this -3, but also to that 5. So I'm actually adding that 1 to all 3 parts of that inequality. I end up getting -2 is less than or equal to 2x is less than or equal to 6. So my second part is the same exact thing, same exact idea. We're going to get rid of that 2. We get rid of the 2 by dividing everything by 2. Then I end up getting -1 is less than or equal to x is less than or equal to 3. And that is actually my answer. So once I have that, the graph is actually not too bad. So make sure once again you're putting the graph on the same number line. Everything goes together on this one for all of these problems. So first of all, we know that x is less than or equal to 3. So what I'm going to do is I'm going to do a closed circle. Make sure you do that. And I know that less than or equal to 3 is stuff that's to the left of 3. It's things like 2, 0, all the negatives. So I'm going to go like that. I'm not going to draw my arrow yet. The reason I'm not going to draw my arrow is because I'm actually going to connect to that part. So then this other part tells me that -1 is less than or equal to x. That's the same thing as x is greater than or equal to -1. So that means that my x is also going to be all numbers greater than -1, including -1. So it can be like 0, 1, 2. So what I'm going to do there is I'm going to make a closed circle again, and I'm going to show that I'm going to the right. And so my answer actually is going to be everything that's shaded in between these two dots. So I don't know, once again, I don't know what my x is, but I do know that it's between -1 and +3. So actually, this is the second part of my answer. Okay, I want you to see if you can try this one on your own. So go ahead and pause and try it. So for this problem, I'm going to start by getting rid of that 1. I'm trying to get that x by itself. I move over the 1 by subtracting it from everything. So I get -6 is less than or equal to 3x is less than 9. That's my first step. Second step is to divide everything by 3. I end up getting -2 is less than or equal to x is less than 3. Last step is to draw my graph. So my graph, I am going to have a closed circle with the -2, and I'm going to have an open circle with the 3. So I know that my x is going to be bigger than -2, and I know it's going to be less than 3. And so I'm going to shade in everything between these two dots. You'll notice that with pretty much all of the and inequalities, I'm always going to have something that looks like this. I'm going to have two dots with stuff shaded in between the dots. So in general, that's the way that most of these are going to look like. This next example is a little harder. You'll see that there's a little bit more going on with it. And you're going to find that the reason for that is because of the negative with that too. So if you want to try it on your own, feel free to pause and try it. So what we're going to do for this one, it's going to start out the same as all of the other problems that we've been doing. You're going to subtract the 3 from everything. You get -2 is less than -2x is less than 16. Next part is where it gets weird. So now you're going to divide everything by -2. However, if you remember, we have a special rule when dividing and multiplying by negatives. So what's going to happen is this is going to become 1, this is going to become x, and this is going to become -8. But unfortunately, we need to remember to reverse our inequality signs. The other thing I would like you to try to remember to do is to turn things around so it stays in order. What I mean is that I want it to be in order from smallest to largest. So we know that -8 is the smallest, and we know that 1 is the largest. So the arrows still need to be pointed the same way. You're still pointed towards the -8, and you're still pointed towards the x. So make sure that you end up getting that in the end. And that's actually our answer for this one. I'm also going to draw a number line and try to draw the graph of it. And for this one, I'm going to go by 2s just because I have more, it's more spaced out. So what I'm going to do is I know that this is an open circle. It's going to be an open circle between 0 and 2 for 1, and everything in between is going to be shaded. So this one is not that hard, except that a lot of people tend to forget the rules about working with negatives, and they also make a mistake when they try to switch it back around. So please make sure, though, that you write it in order from smallest to largest. So here's our last example for the day. I would like you to give it a try. Pause, please. So what you're going to do is you're going to start by adding 3 to all 3 parts of this inequality. You end up getting -2 is less than or equal to -x is less than or equal to 5. If you want, you can add a 1 with that negative, or you can skip adding the 1 and just remember that it's a -1x. So we end up dividing everything by -1. That gives you +2 is greater than or equal to x is greater than or equal to -5. Don't forget that you need to reverse your inequality signs. The last thing I'm going to do is to switch it around so that my inequality is in order from smallest to largest. So then I'm going to draw my graph. Once again, I'm going to go by 2s. Sometimes if you get big numbers, you're going to go by like 10s or 5s or something. That's fine. So I'm going to draw my first dot. It's a closed circle at -5. Second dot is going to be also closed at 2. And this is also going to include everything between them.